डिरेक्शनल डेरिवेटिव और सिंपल डेरिवेटिव का डिफरेंस क्या होता? मतलब तुम लोग जब कैलकुलस 1 gone through, you have learned differentiation of a function of two variables. You have learned how to make differentiation of fxy कैसे होता है ये पढ़ाया गया कैलकुलस 1 में। तब एक चीज जरूर तुम्हें याद है और कुछ याद रहे ना रहे कि हम लोग ये डिफरेंस लेते थे fx प्लस h y प्लस k माइनस fxy, ये डिफरेंस हम लोग जरूर लेते थे। तो इसमें क्या वो था डिफरेंशिएशन ऑफ fxy। तो हम लोग ये अगर मतलब fxy एक पॉइंट पे उसका फंक्शनल वैल्यू हो तो x प्लस h एंड y प्लस के हम लोग ये जो पॉइंट लेते थे जिसका x कोऑर्डिनेट होता था x प्लस h एंड y कोऑर्डिनेट होता था y प्लस के, दे आर पॉइंट्स। तो अगर तुम्हारा ये xy हो, इसमें अगर xy ये पॉइंट कोऑर्डिनेट xy हो तो x प्लस h y प्लस k मतलब एक नेबरहुड का पॉइंट होता था, एक नेबरहुड का पॉइंट होता था और इसमें फंक्शनल वैल्यू का डिफरेंस जांच करते थे। यहाँ पे क्या हो रहा है देखो, यहाँ पे भी डिफरेंस ही हम लोग ले रहे हैं लेकिन we are not taking the points from a neighborhood. We are taking it from a straight line. एक स्ट्रेट लाइन के ऊपर से वो पॉइंट ले रहे हैं। तो यही है मतलब तुम्हारा जो मेन डिफरेंस है कि जब हम लोग डिफरेंशिएशन ऑफ टू वेरिएबल्स करते थे तो जो नेबरिंग पॉइंट लेते थे वो नेबरहुड से लेते थे, लेकिन यहाँ पे जो हम जब डायरेक्शन डेरिवेटिव कर रहे हैं तो देखो P0 पॉइंट पे हम लोग डायरेक्शन डेरिवेटिव मतलब निकालेंगे तो जो नेबरिंग पॉइंट ले रहे हैं वो भी उस स्ट्रेट लाइन के ऊपर ही ले रहे हैं। तो rate of change of f but in a particular direction we are taking. So this is the main difference of directional derivative and simple derivative of a function of two variables. This is a problem which you have seen that is quite easy to calculate. Acha. Now let b be any unit vector and p not be any point. So now the main difference from the what we have just covered is यहाँ पे 3 component है. So now we will deal with function of 3 variables. We have done for 2, now we are going to 3 variables. So let b be an unit vector. So whenever you are getting a unit vector in your back of your mind, what will work? That we are going to define directional derivative of a function. So the direction will be fixed by this unit vector. So whenever I am giving you a unit vector in the context of directional derivative, in your brain it will work like that. So this is the direction in which we have to find the directional derivative. Okay. So not only a vector will do, उसके साथ एक पॉइंट भी जरूरी है और ये पॉइंट का x, y, z कोऑर्डिनेट है a1, a2, a3. ठीक है. Then the equation of a straight line passing through this point and parallel to this vector is given by this. Obviously it will be. हम लोग जब दो वेरिएबल के लिए किया उसमें देखा यहाँ पे 3 वेरिएबल है, nothing more different. Okay. So now what will we do? We will check this difference. So we will study df ds, which will be by definition limit s tends to 0 f of a1 plus sb1, a2 sb2, a3 sb3 minus f of a1 a2 a3 divided by s. This one we will study. If the limit exists, then very good. That means I have got my directional derivative in the direction of this unit vector. So whatever I have done for two vectors, two components, this is for three components. Nothing difference from there. Okay. Now you see one thing. In calculus 1, we have learned something called chain rule. Chain rule we use for differentiation of function. Remember, you have learned chain rule. So how was the outset? W was a function of three variables, x, y and z. And each of x, y and z are function of t. So W is a function of x, y, z which is differentiable, and each of x, y and z are differentiable function of a single variable t. So now then your W will ultimately become a differentiable function of t. So how was it? F was a function of x, y and z. X was a function of t, y was a function of t and z was a function of t. So f become a function of t. Ultimately f become a function of t. And not only that, if you're not f, it is w. Now w is a differentiable function of x, y and z. What do you mean by differentiable function of three variables or two variables? That you have done in your calculus 1. So W is a differentiable function of x, y and z. And x, y, z, who are functions of t, they are also differentiable. So ultimately, your W will become a differentiable function of t. So W is a differentiable function of t. So now I will ask, what will be your dW dt? So this was the chain rule by which we have computed dW dt is actually Wx. Wx means del W del x. Wy is del W del y and Wz is del W del z. So dW dt is del W del x into dx dt plus del W del y dy dt plus del W del z dz dt. So this was your chain rule. Why I have recapitulated this thing? Because now in the direction derivative I will use it. How I will use it? So you know, you have whatever you have found out, it is df ds. And how did you get your df ds? Remember, your function f was a function of three variables, x, y and z. X, y and z, you are taking them from a straight line. This was the region R and this was a straight line. You are taking the points from this straight line. So x, y, z, they are x coordinate, y coordinate and z coordinate of points from this straight line. So that is why your x was x0 plus SU1 type, y was y0 plus SU2 type and z was z0 plus SU3 type, where this is your P